Okay, slide 44 is about the recursive formula. A recursive formula tells you to find the nth term of the sequence by performing operations to the previous term. For a recursive formula, the first term is always given. The way they give you that first term is your A1. So make another text box and we're going to put A1. Do you remember how to do the subscript?
Control comma.
Control comma. So A1, control comma to come back out of it equals first term. Okay, so they've given us a recursive formula. When they give it just like this. So let me zoom in a little bit. So they give you the first term. So this one, it says A1 equals 5. So we will write 5 is the first term. Make my little box a little bigger. So when we write our sequence, it'll be 5. 5 is your first term. Then the next thing, it says AN. So this is your formula. The way you know it's a recursive formula is it says AN equals, and then it has this AN minus 1. N minus 1 is going to be your term before it's just term before. So this one says 2 times the term before plus 1. And then this says n is greater than or equal to 2. And so this means use the formula to find the other terms beyond, to find the other terms starting with 2, starting with the second. That box is just not big enough. Okay, so we are going to use this to find those terms. So get out your composition book, and we are going to find those next terms. Okay, so this is what my next page looks like. Recursive formula, slide 44. And so our first example is A1 equals 5, comma, AN equals 2 times A subscript N minus 1 plus 1. N is greater than or equal to 2. our first term is 5, and then all the terms after that we can use the formula for. So our first term, A1. So then we're going to find A2. A2 is found by doing the formula. A times your previous plus 1. So this would be 2 times, what's the previous?
5.
Yeah, because this is your previous or the one before. Times 5 plus 1. 2 times 5 is 10, plus 1 more is 11. Then A3 is found by doing 2 times the previous. What's the previous before the third one? It's 11, yep. Plus 1. 2 times 11, plus 1 more.
2 times 11, not 3 times 11?
Yes.
No, because the formula says 2 times the previous, plus 1. So that'd be 2 times the previous. This is your previous, plus 1. 22 plus 1, 23. A4. 2 times your previous. What's the previous?
43.
23 plus 1. So that would be what? 47? Okay, let's just do the fifth. It'd be 2 times 47 plus 1. What's that?
95.
Yeah. So the sequence, we can list out the sequence as 5, 11, 23, 47, 95, dot, dot, dot. Okay, so that is our sequence. Is this arithmetic?
Oh, yes. No, but yes.
Plus 6, plus what? 12, plus 24.
No.
Okay, so it's not arithmetic because we can't add to get something. What about geometric? Can I multiply 5 times something to get 11?
No.
Because that'd be what? I don't know. We divide them. 11 divided by 5. 2.2. What about 23 divided by 11? Nope. Okay, so I'm just going to put not geometric or arithmetic. Oh, I put no. I should put not. There we go. So it's neither. Do what?
So how's your Halloween?
Okay, let's keep on going. Okay, let's go to this one. We're actually going to delete slide 45. So click on it and click delete. And then we're just going to the new slide 45, which is this one. If you did the wrong one, edit undo. Okay, so you should be on this slide now. Okay, we are going to do these 6 problems. Actually, I really only want to do 3. We're just going to do a few of these. All right, so write down in your journal, recursive formula practice, slide 45. And then write down your first. We can fix his slides later. He can just do this right now. All right, so let's look at this problem. It says A1 is -4, and then we have AN equals 3 times AN minus 1, or N is greater than or equal to 2. So remember, this is your first term, and then the AN minus 1 is your previous. So it's just going to be 3 times the previous. So this will look like, let's put A1 equals -4, and then let's find A2. So A1 says -4. A2 is 3 times, I'm going to put it in parentheses, the previous. So 3 times the -4 gets -12. And then A3 is found by doing 3 times the previous. You're doing the same thing. 3 times the previous. What's the previous? -12. So 3 times the -12. -36. Find A4 and A5. Sure. Yes, you may use a calculator. And then list out the sequence like we did for this other one. And then decide if it's arithmetic, geometric, or neither. Okay, A4 is found by doing 3 times the previous, so 3 times the -36. What is that? -108. Okay. The fifth one, 3 times the previous, so 3 times the -108. I don't know what that is.
-324.
Okay, good.
And a half. Okay.
And then we can write our sequence, starting with A1. So it'd be -4, comma, -12, comma, -36, comma, -108, comma, -324, comma, dot, dot, dot. So if we look at our sequence, how it's going up, or actually going down because it's getting smaller. Is this arithmetic or geometric?
Geometric.
Okay, what is the common ratio? What's the number being multiplied?
Oh,
3. So times 3, times 3, times 3, times 3. So yeah, it's geometric. Common ratio is 3.
Wait, so does D equal 3 also?
That's only for
D is arithmetic because that's your common difference. Okay, so this formula right here is your recursive formula. It's what we learned today. But last week we learned the explicit formula. So you have two ways of finding the next term. You can either use the recursive formula and keep on multiplying until you get to the term that you want, or you can use a recursive formula. So let's look back at our notes. And let's look back at what the recursive formula is. We're going to write down AN equals A1 times R n minus 1. So see how the recursive formula has a n minus 1 where n minus 1 is your subscript, but the explicit formula has it as an exponent. So that's how you would know if it's a recursive formula or not. It has the subscript a n minus 1. That's always the case with the recursive. So I'm going to write down my formula, and then we're going to fill in what we know. So AN equals A1 times R raised to parentheses n minus 1. So we're just going to write the formula. That's all we have to do. So we would write AN equals, what is A1?
first term.
Which is -4. So we're going to put it -4 in parentheses times, it says R. What is R? 3, the ratio, common ratio, and then raised to the n minus 1. So this is the explicit formula, and this is the recursive formula. They both have the 3 in common. They have a -4 in common, but that's written in a different way. See how it says A1 equals -4? So for the recursive, it's going to give you A1 separate. For the explicit, it's going to give you A1 inside the formula. Okay, let's go to example 2. I need to turn my page because I filled up that page. So we write A1 equals 5, comma, AN equals 2 times AN minus 1, where n is greater than or equal to 2. I'll show you my screen now, or my paper. Okay, so this is the recursive formula because it gives us A1 equals, and then it writes the formula where this is what you're finding, and then the A times n minus 1 is your previous. So what operation's happening between terms? Multiplication, yep. So let's write A1 equals 5. So then what is A2?
5.
No, it's 2 times the previous. So 2 times 5. A n minus 1 is your previous. So we're finding 2, the second term. So your previous is the first term.
Minus 1, right?
Nope. This is A n minus 1 is your previous. See how that's all as a subscript?
Yeah.
Don't have to do anything else. The only operation that's happening here is 2 times your previous. So that equals 10. So then to find A3, we would do 2 times the previous. What's the previous? 10. 2 times 10 is 20. Okay, A4 would be found by doing 2 times the previous. So 2 times 20.
40.
All right, the fifth term. 2 times 40 equals 80. So we have the first 5 terms of the sequence, so let's write those.
5, 10, 20, 40, 80.
Dot, dot, dot.
Dot, dot, dot. That means it goes on.
All right, what kind of sequence is this? Yeah, how did you know?
Times 2.
Yeah. So we're going to put geometric, and then R equals 2, because it's times 2 every time.
Perfect.
Okay, this is your recursive formula. Now we're going to write the explicit formula. So it's AN equals A1 times R raised to the n minus 1. And the reason we find the explicit is so that if we were asked for the 50th term, then we could just plug in 50 into our n value. So AN equals A1, we already know because we were given it in the recursive formula, it's 5, times R, it's what's being multiplied each time, raised to the n minus 1.
Perfect.
Perfect. Okay, we're going to do one more example. We're not doing all of these. We are doing number 3. And it looks kind of bad. Like it doesn't look right because there's no equal. These minus that's right here should be equals. So I'll write it down so y'all can see it. So this is how it should look. A1 equals 8. AN equals AN minus 1 minus 6. No, it's not hard. What's happening to the previous each time?
Minus
going up.
6.
Down.
Negative.
Down. It's subtracting 6.
16 and a half.
All right, so let's write A1 equals 8. A2. This recursive formula, remember this is your previous. So let's write previous underneath there. A n minus 1, that's your previous term. So to find A2, we would plug in the previous. 8 minus 6.
Oh, he's a trap.
Oh.
Yeah, because that's what it says right here. Subtract 6. So 8 minus 6 is 2. There we go. And now A3 equals, we do the previous. What's the previous? 2 minus 6. So minus 6 is going to be part of the equation each time because that's part of our formula. 2 minus 6, you can change it. Keep, change if you want. And it's 2 plus a negative 6.
4.
Negative 4. Use your calculator if you need to. I know negatives can kind of get confusing. All right, A4. So look back at the formula. It says previous minus 6. The previous would be
Negative 4
negative
minus
4.
6.
If you want to do keep, change, or if you want to put it in the calculator, that's fine. I'm going to do keep, change. Negative 4 plus a negative 6.
Negative 10.
Negative 10.
To the second power of 17.
Okay, and then the fifth term is the previous minus 6. What's the previous? Negative 10 minus 6. Keep, change. Negative 16. So let's write what our sequence is. It is 8, 2, negative 4, negative 10, negative 16, ... What kind of sequence is this?
Arithmetic.
Yeah, it's arithmetic. How do we know that?
Oh.
Because if we go from 8 to 2, what happened? What's the operation?
Minus 6.
From 2 to negative 4.
No.
Negative 4 to negative 10. Negative 10 to negative 16. So each time we're subtracting 6. So for arithmetic, our common difference, D, is negative 6.
Ooh, nice.
Okay, so let's remember what our explicit formula is so we can write that down. I need to go back up on my slides. Here's my explicit formula. A1 plus n minus 1 times D. And so we're going to plug in what we know and then simplify. So this would be AN equals, A1 is from over here, is 8, plus n minus 1 times D. D we found right here, yeah, negative 6. We're going to simplify it. So distribute. AN equals 8. Negative 6 times n.
Negative
6n. And then -6 times a -1.
Positive 6.
Plus 1. 6. Yeah, you're right. Sorry. Got a little confused there for a sec. And then we combine terms. Combine like terms. 8 and +6 can be combined. But I really want to have that -6n out first. And then 8 plus 6 is 14. So this is my explicit formula. Okay, so we are done with the notes. So let's look at the back of that maze. Or let's look at the maze real quick.
How are we gonna set up emissions?
Oh, we need to put that into our digital notebook. Sorry. Go back over here and take a picture and put that in here. We only did 1 through 3. So take a picture and put that in there. I'm going to pause it. Okay, so now that you've put your picture in here, let's look at that maze worksheet. If you did this correctly, you should have gone through each one of these, but there should be a particular order. So remember, if you need to look back at Friday's video, make sure that you put an arrow on each one and also write whether it's R equals or D equals. So this one was D equals 10, okay? So make sure that you do that for each one, and you will actually go through each one of these. So if you end up back here at the end before you have done each one, that means you made a mistake along the way. Okay, let's look at the back side because you're going to finish this as your assignment. We're going to write the recursive and the explicit formula for each one of these. We'll write the recursive first, and then you can find your explicit from that. So we're going to do number 1 together. A1 equals. So for each problem below, write the arithmetic explicit formula and recursive formula. Then use your formula to find the term. So number 1, A1 equals 1. And then what about A1 to A2?
Plus.
Okay. And then from 3 to 5. Okay. So our common difference is 2 or plus 2. Our recursive formula is written as AN equals AN minus 1. And then what happens to the previous to get to the next one?
You add 2.
You add 2. So we'd say AN equals AN minus 1 plus 2. That is your recursive formula. That's it. And then your explicit is this is arithmetic, right?
Yeah.
So it's AN equals A1 plus N minus 1 times D for your explicit. So that's what we'll write. We'll write AN equals A1 is 1 plus And then part of the formula is n minus 1 times our common difference times 2. So we are going to distribute an equals 1. Then we're going to multiply 2 times n and 2 times the negative 1. So plus 2n minus 2. And then combine the 1 and the minus 2. And we still have the 2n. So an equals 2n. 1 minus 2, negative 1. So this is your explicit formula. To find your 34th term, you'd plug in 34 for n. So A34 equals 2 times 34 minus 1. So 2 times 34 minus 1. Okay, and then minus 1. So 67 is the term. So you actually have 3 answers on each one. You have the recursive formula, the explicit formula, and the 34th term. Okay, number 4 is going to be bonus. Okay, so you just have to do 2 and 4. Number 3, sorry. Number 3 is bonus. Okay, and then number 4 will be bonus on the bottom part. Okay, let's do number 1. For problems below, add geometric explicit formula and recursive formula. Okay, let's look at number 1. 2, negative 6, 18. G1, this should really say A1. I guess they were just trying to say geometric. So this one should say A1 too. So the sequence A1 would be 2. And then your common ratio, what is happening to each one before it? Remember, to find that, you would do A2 divided by A1. We learned that last Friday. So it would be negative 6 divided by 2. Which equals negative 3. So our common ratio is we are multiplying times the negative 3 each time. So our recursive is just found by saying an equals, what's happening to the previous? You do your common ratio times your previous. So we'd write this as negative 3 times, our previous is written as an minus 1. And then the explicit formula for geometric is an equals a1 times r raised to the n minus 1. Right up here. So we'd write this as AN equals A1. Well, what is A1? I should just write it, huh? Two times R, which we found right here, -3, raised to the n minus 1. We can't simplify that at all. So we just leave it just like that. And then to find the fourth term, we just need to multiply, or we need to plug this in. So you can put this in the calculator. A4 equals 2 times a -3, and then 4 minus 1. 2 times -3 raised to the 4 minus 1, which gives -54. Okay, so all you have to do is 2, 4, 2, 3, and any bonus you want to do.